Hello everyone, this is Daniel Pinheiro from danielpinheiro1982.com and welcome to this course, Python Programming, a hands-on course for beginners. The aim of this course is to give you the basics in a most complete way so that you can be pretty self-assured about knowing everything you gotta need to know about Python in order to start learning data science and machine learning. So this first lecture will start with a brief theory for contextualizing what Python actually is, and right after we'll start developing our first code with Python, with anaconda and conda, creating our virtual environments, and using Jupyter Notebook or jupyterlab as our IDE in order to show you how to create one very simple project with Python. So let's start. So what is Python? Python is a programming language that you can use either as a script language or in a object-oriented perspective. So in data science and machine learning, you mostly use it as a script language, but you can also develop any kinds of software with it, and then you probably use more the object-oriented perspective of Python, which is not the object of this course. In this course, we'll show you how to use Python specifically for data science and machine learning, so basically as a script language. So here are some basic core functions of Python, of the Python lab. We have a vast variety of functions and methods of objects outside the core package of Python that we can import to our code, but we also have the core package or the core set of packages of Python that already comes with the Python installation itself without the need to use or import other packages from outside. So, for example, the print function here is part of the core of Python, so that's why you call it directly at the code without having to call any object or any package. And we'll see how to call those external packages later, but for now we're just showing an overview of the basic structures of Python. That's why all the structures here are from the Python core itself. So the print function, between parentheses, the string that we wanna output to the console or to any output of the program we are writing, either under double quotes or single quotes. So we can either use single quotes or double quotes, just having care to, for example, if we had to use single or double quotes here on the middle of the sentence, we can alternate to not close the double quotes in a wrong way here inside. So we'll see all this later when we write our first program. So here's just to show you the print function and how to output a string message. So between parentheses and double quotes, you put the string message, either a char or a set of chars in a string sentence. And then the program outputs the string sentence to the console. So we also have the input function, which is also part of the core lab of Python. The input function will receive an input from the user, and for the user it asks, for example, what's your name? And when the user types his name, that input the user inputs to the program will be assigned to this left side variable called name. So this name word here in case you don't know, is a variable. In Python, we do not have to set or define the type of the variables we are assigning any expression or result to. It's automatically assigned. So for example, here to store a name into a variable called name, we use here the input function with a question to the user, for example, what's your name? And when the user types an input and press enter, for example, if the input is Daniel, the program will store that string input Daniel to the name variable. And then using the variable, it can, for example, output any other message. This is the other print format that I referred to, using the f inside the parentheses and outside the single or double quotes. Why? Because doing this indifferently from this other print here at the beginning, with the f attribute here, right outside the single or double quotes of the sentence between the parentheses, we can, for example, call any variable here from inside the sentence we're outputting. For example, using curly braces and the variable name inside. And then Python will output the sentence with the value of that variable name that we put here inside, between curly braces, between the single or double quotes, and after the f format attribute here. So we have this first simple way of using print, but we have this better way of using it with the f attribute, so that you can use variables here inside the sentence, and the translator of Python will automatically substitute this name variable here by its value at the time this code is translated. Instead of outputting hi in the variable name, it will output hi and the variable value. For example, hi Daniel, or whatever you have set to this name as an input here. For example, here it inputs the name you set for the variable name, and here it outputs the value that you have set here above in place of the variable name here in the middle of the sentence. So if I have input Daniel as the name variable here, it will output hi, Daniel. Here we have an example of how to iterate data structure. In this case here, a list. And don't worry about data structures, we'll see all of them in a specific lecture. Here's just an example to show you an overview of it. So here on the right we have a definition of a list with 4 elements. The elements being 2, 4, 6, and 8. So 4 elements. And the list itself as a whole being assigned to the numbers variable. And here down below we have the product variable being assigned the numeral 1. So here, just as an example of a loop, we have a for structure, and the in keyword here will make this variable, this temporal variable here, this local variable number that we called number, but we could call it any other name. So for this list called numbers, and for each element of it at each respective iteration, we wanna reassign the product value, which initially is 1, to the product of the product times the current number at that current iteration. So initially we have product as 1, being multiplied by 2 and assigned to product. So this is a recursive assignment. Product, which is initially 1, is assigned to product itself times the first element of the list, which is 2. So product at the first iteration ends up as 2. Then at the second iteration, product, which is 2, is assigned to 2 times the second number here. Now that we are at the second iteration, the second number is 4. So 2 times 4 equals 8. Then at the third iteration, we have the assignment for the product variable as being 8 times 6, which is the third number here of the list. So 8 times 6, it's 48. And at the last iteration, for the number 8, we have the product being assigned to 48 times 8, which is 384. So here outside the 4, pay attention that everything that's indented after the loop structure will be repeated at each iteration. And for marking the ends of the loop, you simply eliminate the indentation. So in this case, print is not inside 4. It will simply be executed once. So after the 4 ends, then we have the execution of the print function with a string sentence, the product is, then the common and the product variable here, which will translate into the product value 384. So this print here, if you see, is similar to this first print here. It's the traditional print, but you could also use this better print function here, which is another function, using the f attribute with the variable here inside the string sentence itself, with the curly braces marking the space at that string sentence where the value should be outputted. So here on the third example, we'll have the definition of a function called fab. We can define any function we want, except by using names that are already reserved words, or for already existing default or custom function names. So assuming that we have no fab named function in our code, we can define, using the def keyword, we can define a function called fab with a parameter called n. And then inside, with the correct indentation here, if you see, we'll process that input. For example, when the user calls that function fab with an input of 1000, that 1000 will be assigned to the n parameter as an argument, and then that 1000 value will be processed here. Any process you might have implemented. If the user calls the same function with another value, for example 2000, then the 2000 will be assigned to this n parameter here and will be processed the same way, but with different results, as the input now is 2000 and not 1000 anymore. So we create functions to reuse those functions later at the code or at other programs that import a certain package where we have defined those functions, and then the user will use the imported package to call that or those already implemented functions implemented by other people in his own code. This is what gives Python actually its greater advantage, which is the large, vast set of packages, already implemented methods or functions that we can import to our code, to our data science and machine learning code, to simply pass some input and have the output without even bothering to get into the function or the method to know how it's implemented. So there's a lot of complex stuff in data science and machine learning that we wouldn't want to implement from zero, so we simply reuse other people functions from external packages inside our code and get the results and expect those results to be correct. So here, when we call the fib function with the 1000 value, it will just output the Fibonacci sequence for the 1000 value. Here on the fourth example, we defined another list with 3 elements, banana, apple, and lime, to the fruit variable. And down here, we're using a list comprehension, and we'll see exactly what it is later. We have one class for studying comprehensions, list comprehensions, and other data structures comprehensions. But basically, what a comprehension is an iteration of a certain data structure. For example, here a fruits list, and for each iteration the value is set here as fruit. But additionally, we have here the process of setting, for example, the name of the fruit to uppercase, and that defines another list, another result or output list with the processed outputs. So here's the original list, but after we use the list comprehension, we have another list saved at this other variable name here, loud fruit, which is basically the same element names but in uppercase. So here we iterate each of the elements and turn them to uppercase and store to another list. So this is typically a list comprehension, and we have comprehensions for other data structures that we're gonna see. So basically this is the key idea. This other part here is just using the enumerate to create another list with tuples. We'll see these later. Tuples is another data structure that we have, and we can have, for example, data structures inside other data structures. So here we have a list, as we have seen already, with the square brackets. But inside the elements, instead of being simple strings or simple numerals, they're actually tuples with 2 elements inside. One is 0 and the string banana. The other is the 1 and the apple string, and the other is the 2 and the lime strings. So basically the enumerate enumerates and creates indexes for each of the elements of, for example, the list it's enumerating. So don't worry with this. You'll see all of that in details. Here is just a general overview for you to get known to Python. This last overview example just shows you that, for example, you can execute simple arithmetic functions directly in Python. For example, 1 divided by 2, it will output the result of the arithmetic equation or expression, which is 0.5. 2 and double asterisks or double stars means 2 to the third potency or 2 elevated to the third potence. So it will be 8, and we'll see all, not only these, but a lot of other math operations later. Here we have 17 divided by 3 for showing an example of float to number output. 5.666 and a 7 at the end. And at this last expression here, we have 17 /3, which is the floor division. If we divide 17 per 3, we have 5 and a rest of 2. It takes only the 5 and ignores the rest. So this is the floor division. It only takes the integer number of the result of the division. So here are some basic characteristics of the Python language. Python was created by Guido van Rossum from Netherlands in the late 80s. So it's not a new language, it's actually older than Java, for example. People think the other way around. They think Java is older than Python just because generative AI is very recent and it has stimulated the use of machine learning. And for machine learning, we basically use Python, although we could also use Java as well. Python has been created in the 80s, and its first public release was only in 1991, still before Java. The first Java release was 1995. The last version of Python is from June 2026, which is the version 3.14.6. Python is pretty much easy to learn. It's a powerful, high-level, general-purpose, as I said, and cross-platform programming language. So we can program any software in any OS, for example, in Linux, as I do, in Windows or in Mac OS, and you will use the exactly same language structures as well as tools. For example, conda and anaconda and the IDEs, they are all the same for any operating system you're using. So it's also multi-paradigm. Python is a language which is imperative, structured. For example, when you write a script, you're simply using the structured behavior or overview of the language, but you can also construct object-oriented software with it. So you would both use object-oriented programming and structured programming. It's also a generic, declarative language. It has functional programming structures, aspect-oriented as meta-programming and meta-objects. It has also the reflective paradigm. It's extensible to other paradigms through third-party libs. It also supports the concurrent paradigm, distributed, visual, and constrained programming. So these are very specific characteristics of the language just to mention, but of course you don't have to memorize any of these. Only know that it exists, and later if you need to reveal it, you know that Python supports all of these paradigms regarding programming languages. For example, if you want to compare Python with Java or Python with C++ or Ruby or JavaScript and whatever. Each programming language will support specific programming languages paradigms. Another characteristics of the language of Python, it's dynamic typing. So you do not set in advance the types of the variables. They are set dynamically according to the values. It has an elegant syntax. It has high-level data structures, as we've briefly mentioned. We have lists, we have sets, we have dictionaries, we have tuples, and we have many other derived data structures from external labs. We'll see those in our practices. Python also has garbage collection and simple object-oriented definitions. For example, as Java, it has inheritance. Actually, it supports multiple inheritance differently from Java, that only supports single or simple inheritance. It has polymorphisms, dynamic linkage, and all those common object-oriented properties for any language that supports object-oriented programming. So Python is object-oriented, but in our case specifically, we won't need to use Python towards this paradigm. We'll use simply as a script language, so as a structured language, but not specifically, or at least from our part, manually as an object-oriented programming language. But you could, depending on the software you're programming, you could use the object-oriented programming the same way you use it with Java or C++. For Python, it's actually optional. Also, we have dynamic resolution or late binding. The method and variable names are bound at runtime. Python is ideal for scripting, as I've already mentioned, and rapid application development. Not only because of its simple syntax, but because, for example, you don't have to use any complex paradigm with it. You can simply write a simple script which turns the code somehow simpler than if you had to write more complex designs. Although that will depend much on the application that you're creating. For example, if you're creating other types of applications with Python, then you probably should or could have to use object-oriented as you do, for example, in Java or C++. We have classes with their methods. In the case, for example, we don't have to design object-oriented programming, but we'll be using a lot of objects from external labs or external packages that inside are object-oriented. So we'll be using classes and their methods, or we'll be using procedural standalone functions, for example, the core inbuilt functions or external functions from other packages, which are independent from objects or classes. They're simply standalone functions that you can use directly without calling any object related to any respective class. So we have lots and lots of third-party extended labs from the core Python lib. The most used, especially in data science and machine learning, is numpy, pandas, matplotlib, plotly, scipy, seaborn, scikitlearn, and etc. So this course will not tackle in detail any of these external labs. It would turn the course a too big course for its intended workload. So we'll tackle basically the core lib of Python, but have in mind that this core lib of Python derivates optionally in many other external labs, and these external labs are actually the main advantage of Python in data science and in machine learning. So theoretically, you could create any program with the basic core lab of Python. In any of these labs, they actually do that. They use basically the core of Python to implement external function or external classes for you to create objects from them and use their methods at your project. But most of those methods and functions are very complex ones. That's why we reuse them instead of creating them from zero. So it's very, very common to import external packages in addition to the core packages inbuilt to Python. And you actually can create your own package for any context you decide and turn that public for others to import your package and reuse any function or method you have created inside. So, other than that, Python is an interpreted language. So when you write, for example, your script, you have the interpreter of Python, which is freely available as an open source that goes line by line interpreting and translating your code into machine code for your processor to execute. So interpreter is freely available along with a lot of awesome third-party modules, programs, tools, additional documentation, and a hugely supportive community. The interpreter is easily extended with new functions and data types implemented in C and C++. So it's not uncommon that Python is mixed with other programming languages, as C++, for example, and translated with the same interpreter if that interpreter is extended to translate or support other languages as well as Python. But we'll focus on our course basically on Python. So here, just as a reference, we have the domains or the URLs of each of those main labs or packages that are extensively used in data science and machine learning, which is numpy, pandas, matplotlib, seaborn, plotlib, scipy, and scikitlearn. You can see or check here on the right each respective site for those labs. Every lab in Python has its own site with its own documentation and its own supportive community. So if you want to know about any lab or any external package, especially the most famous ones as these, you can simply type it, the name of the package at Google or any other searching engine, and it will show you the respective site or domain or URL for that package. But all of these packages have in mind that they are written in Python and they are extended from the core lib of Python. So all of this is Python, but with reusable functions or methods written by other people, and generally very smart people. So we have very complex statistics and math methods and functions that we can reuse without having to implement all of those for later use at our projects. We simply import these packages and we reuse any function or method that are implemented by the smartest people in the world. So that's the big advantage of Python or any programming language that can import others' packages into someone's project, which is the reuse of code. And that's also true for Java and for C++ or for any other programming language. So here's some of the applications of those 30-part libraries. They're written for console applications, web applications, desktop, graphical user interfaces, scientific and numeric software development tools, education, business, games, audio, video, image processing, CAD, network softwares, SEO, and database programming. Python is a very general purpose language, so it can be applied to basically any programming context or any programming problem solution context. So for writing our code, we can actually use a simple text editor, but you do not have much resources on those. So although you could use, for example, in Ubuntu, the gedit for editing a Python script and later executing it, for example, by calling the interpreter Python and the name of the script that you have written with the .py extension. It would execute the script with the Python interpreter, but we generally do not do that. We use a specific and well-designed IDEs, for example, VS Code. We also have PyCharm, which I prefer. This from JetBrains. This is from Microsoft, but I prefer PyCharm. We have Spider, which is more an academic IDE. I do not like it much. And we have the most used IDE, which is the one we're going to use in this course, which is jupyternotebook or jupyterlab. This is the main IDE used nowadays for Python, specifically in the case of data science and machine learning. So that's what we're going to use in this course. But just have in mind you have all sorts of possibilities for writing your code and just saving it into a Py extension file, which is then interpreted by any interpreter you download to your machine, for example, the Python C interpreter or whatever. We also have online platforms with inbuilt IDEs as well as inbuilt interpreters through which you can write your code online and execute it online. And you have a server running that interpreter in an operating system, and it will run your script and show an output for that script. For example, you have the Replit platform, you have GitHub Codespaces, GitHub Copilot, and the most used one that we're gonna use in this course, which is Google Colab. So basically in this course, which IDEs we're gonna use? We're gonna use jupyternotebook along with conda and anaconda, and we'll publish our GitHub project with that jupyternotebook to Google Colab. So we'll see all of it in our first example right in a moment. And here's some more reference that you may check out. First, the Python.org site, which is the main Python organization that takes care of Python core labs and all of the documentation and community assistance and support, all events related to Python, and all collaboration between associations of external packages, Python, and so on. Python's community is vast, diverse, and aims to grow. Python is open, so this is the community philosophy of Python. You can pause the video and read it. We have all of these at Python.org site. We have the Python Discord community with more than 1 million subscribers, myself included. We have the documentation for each of Python versions. For example, this is the last version available now, 3.14.6. It's from June 2026, as we've seen. And if you go here to the site, you can check out the complete and very extensive and well done documentation. One of the advantages of Python is that any of its labs, either core labs or external labs, are much well documented. Basically, all of them have their specific sites, as we've seen, and supported community and so on. So if you wanna check out the documentation of Python, just go to python.org and look for the docs section. We have some other sections at python.org regarding the grants, infrastructure, PyCon event at USA. You can check out the whole site, python.org, if you want. And finally, here I have some suggestions of great books that you can also check out. The Python Crash Course, I guess it's in its 3rd edition, a hands-on project-based introduction to programming. And all these books I have used to create this course, so this one is the #1 bestseller at Amazon. You can check it out there. Also, we have the Head First Python book, a learner's guide to the fundamentals of Python programming, a brain-friendly guide. We have many books of Head First regarding programming and data science and machine learning. And we have this specific one about Python programming language. So you can also check this out. We have this introduction to Python from Dato, Paul Dato. If you're in the programming community, you know that Dato is one of the main authors, not only for Java or C++, but also for Python. He's very didactic, so you can check this out as well. We have this other more advanced book, Python for Programmers, with the big data and artificial intelligence case studies, also from Dato. This other one, Introducing Python, Modern Computing in Simple Packages. It's on the 2nd edition from Bill Lubanovic. The O'Reilly publisher has some awesome books that you can read as well. We have this other one from the same publisher, Fluent Python, a clear, concise, and effective programming from Luciano Ramalho, which is actually a Brazilian author. It's a very famous book, pretty advanced. So if you're initiating properly, you won't start from this one. And here, the final reference is basically my profile. So this is my profile at Udemy. You have also the links for my social networks there as well. My site, danielpm1982.com. You have my LinkedIn, my YouTube, and all that. So this is the link for my profile at Udemy. This is my profile at LinkedIn and also at GitHub. And here is my domain, danielpm1982.com. And that's it. So let's get now to creating our first program or our first software using Python. So let's get to work and let's start coding.